All right, students. Sorry for the delay here. Let's look here at the next thing in the notes packet. This next thing in the notes packet is uh, positive and negative intervals. So when we look here at positive and negative intervals, this is any part of the graph that is above the x-axis, right? So when we analyze pictures, and we'll do that here in just a second, you can see that we'll see some below, and negative intervals are anything below the x-axis. So if we're just kind of seeing how this is shaping here, you can note that these right here, positive intervals, are above the x-axis, and these are below, or those two are above. And this one right here, these are negative intervals because these are below the x-axis. So when we talk here about grouping these two ideas, it's just a quick way to say, hey, when is the graph positive? When is the graph negative, right? For positive, we can see that because this graph goes on forever, it would start at negative infinity. And as I look from, remember, left to right, so as I follow this graph at 0 is when it actually stops being positive, right? Now notice I'm using a parenthesis here. Okay, the reason I'm using a parenthesis is, or excuse me, it looks like it would be at -3, right? Because that's when it's positive. That's when the x value is above the x-axis here. Now, as I continue to go, now I notice it's going into the negative. So it starts at -3, again, still using parentheses, because at -3, it's not negative and it's not positive. All right, it's exactly 0. So as I trace this from -3 all the way down to +3, that would look good as well. Well, notice it flips back here. So I'm finished with the negative interval, and I'm going to create a new interval. Remember, this U is representative of a union. What that means is it's showing that we have two or more intervals in the same description, right? So we've seen that with domain. Now we're seeing it with positive and negative. So the second one, again, is picking back up at +3 this time, +3, and going forever towards infinity there. All right. Let's keep on moseying here. Next, identify where the function increases and decreases. So again, we're still doing this here from left to right. We're going to take a pencil. I have something a little bit different here. I just have a ruler, okay? But I'm going to use it the same way that you could do it. And we're going to put our pencil here on the far left of the graph and begin to trace it. At the point when your pencil is moving up, the function is increasing. And at the point where your pencil is moving down, the function is decreasing. It says, make sure this you're thinking about this kind of like a roller coaster. Another way to think of this is actually like a slope of a line, right? So again, I'm starting here at the left-hand side, and I'm just going to trace it. Again, I'm going to use this ruler here. So I'm just going to trace the graph. And when I do that, I can clearly see as I trace it, look at the slope of this line here, right? It is definitely going down. So this is negative. So it's starting going negative here, right? So we have two different descriptions here. We have an increasing and a decreasing. In this way, we're starting with decreasing. So again, on the far left, it's decreasing here. So from negative infinity, and then as I continue to follow here, sorry, I dropped my ruler. As I continue to follow this here, it looks like it's going to decrease all the way here until 0, right? Because again, we're reading it from left to right here. So the x value from left to right is 0. So we know at 0, it's neither increasing nor decreasing. All right. We know at 0, it's neither increasing nor decreasing. As I continue to trace this, remember I reach 0, look at it here. See how it's horizontal? That's the switch from decreasing and then up into increasing. So now from 0 and beyond, that's what we consider increasing right here, right? So from those two intervals there. All right. This 0 in increasing, decreasing has a specific name. We're going to talk about it here on the next page. It won't be the very first thing, but the very first thing is end behavior here. End behavior is helpful, and we're going to go into a lot more descriptive behavior here towards the end of the semester with this. But it's just a way to show what's happening on the far left and the far right. So if I think about each of these here, and I'm just going to go ahead and draw a standard X and Y axes. And for this one, it just says, thinking through each parent function, sketch the graph and describe the behavior in words. Right? So this is the parent function for this first one right here. Now, think about what the end behavior. What the end behavior means is what's happening here on the far left and far right. I'm not concerned about anything in the middle when I'm talking about end behavior, just what's happening on the far left and the far right. On the far left right here, it looks like the arrow is pointing down, right? So with this arrow right here pointing down, this means that it's going to be a down, right? Or it falls to the left, right? Just kind of a couple different ways we could say that. Falls to the left or it's down. On the far right, let's look at the arrow here on the far right. And again, it looks like the arrow is going up, right? So we could say this is an up here, right? Or it rises to the right. There are 4 different combinations that you could have. Okay, this one is a down and up, right? So that's one distinct combination, down and up. You could also have a down and down. You could have an up and up. And you could have a up and down, right? Those are the distinct ways you could say that. So again, this is a falls to the left, rises to the right. This would be a falls to the left and falls to the right, rises to the left, rises to the right, and rises to the left and falls to the right. So on these parent functions right here, we know this is one of those parabolas right there. And so all I'm looking for is what's happening here on the far left and the far right. Well, again, we're just looking at the arrows. Okay, so let's see here. Gotta make sure that we separate this. This would be considered an up and up. On the far left, it's an up. Far right, it's an up. If you wanted to write the phrase rises to the left, rises to the right, you could do that as well. All right, last but definitely not least, we got the old absolute value function here. Again, what does it look like it's doing here on the far left and right? Well, again, we're just looking at the arrows, okay? It looks like on the far left, it's going up, and the far right, it's also going up, okay? Now, this begs the question. These are just basic parent functions that I've done here, right? But if I continue to think about the next question just below it, it says, what kind of transformations would impact the end behavior? Would shifting it side to side, up, down, left, or right, would that impact the end behavior? What about stretching it, right? Making it skinnier or making it wider? Or what about just flipping it, right? That would be the one that actually impacts what's happening, excuse me, here on the end behavior. All right. So what kind of transformations? It would be any kind of reflection over the x-axis. And what that would do is that would just make it the opposite. So if it was up and up here, it would make it down and down. All right, the last thing that we're going to talk about here on the notes is this last idea. Turning points are the points where x and y on the graph, where a function switches from increasing to decreasing or decreasing to increasing. So I'm actually going to flip back here a page because we have a picture. Looking at this example here, I want to talk a little bit about turning points. Turning points. And again, when did this graph go from decreasing and then at increasing? And so that is a point. So it's at 0, comma, -8, right? That's the actual point where it flips from, in this case, decreasing to increasing. Now, if I were to look here at a separate example, let's just say that this is my graph, and not that we have to really know anything about this, but let's say here is the function that I'm seeing here. The turning points are right here and right there, right? Those are the two turning points. Notice it's decreasing, it's decreasing, it's decreasing. Right there, it flips it back up to increasing. So basically, like the bottom of a hump would always be a turning point. Same with the top of a hump. It was increasing and then it falls back down right at that turning point. All right, so I know that some of you asked for this video. Again, I apologize for not getting it up there sooner, but I'm hopeful that this helps and we can definitely interact about it as necessary. Thanks.